I can define a new procedure that takes a stream and returns another stream just by inspecting and manipulating some elements from the front of the input stream, and then using constream to build something new. For example, let's say I want to square all the elements in an infinite stream. I don't have to worry about the end of the stream, because I'm assuming it's infinite. And in this case, I'll build a new stream, where I multiply the car of s times the car of s, and that will be the car of the result. The rest of it will be what I get when I square stream the Coulter stream of s. Now if I define the integers starting at 3, and then I square ints, I'll just get a stream starting with 9. I do call Coulter stream, but only within the second expression in this constream, so it hasn't been called yet at all. It's only until someone asks me, what's the Coulter of the square stream, that I get the number 16. Now one advantage over iterators is apparent immediately. I can ask for the car of s as many times as I want, whereas with an iterator I was restricted to asking for the next element only once. I would have had to give it a name in order to refer to it multiple times. So there's certainly an advantage in terms of how easy it is to use a stream over an iterator, because you don't have to worry about using up elements, or how it changes when you ask for the next. It's just the stream that's there that starts with a particular element and has a rest that's there if you want it, but isn't there if you never ask. Let's look at a stream that's defined in terms of itself. The rest of a constant stream is just the constant stream. A stream of all ones can be defined by consing 1 onto the front of a stream of all ones. And that gives me 1, and then 1, and then 1, and then 1, where the rest of the stream is just 1, and then 1, and then 1, and then 1, the stream of ones. I can combine two streams by separating each into a car and a Coulter. Like let's say I want to add the first element of s and the first element of t, and use that as the first element of the added streams s and t. And then I add the second elements to get the second element of the result, etc. I would write that by saying I want to constream the result of adding the car of s and the car of t. So this is very typical. The first element in the resulting stream involves the first elements from s and t. Now, the rest is what I get when I add the streams Coulter of s and Coulter of t. Now, once you've defined ones and add streams, there's actually an even simpler way of defining a stream of integers. The stream of integers is 1 followed by the result of adding together the stream of ones and the stream of integers. How does that work? Well, the result, ints, starts with 1. We said that explicitly. And then add streams looks at the car of this stream and the car of this stream, adds them together. And that's going to be the first element in add streams 1's ints, the number 2. And what's the rest? Well, the rest is what you get when you add together 1 and 2, the second elements, because that's what add streams does. It recursively calls add streams on the Coulters. And the Coulters in this case are the sequence of all ones and the sequence starting with 2. And that gives you 3, and similarly you'd get 4, 5, 6, 7, and you'd compute all the integers, as many as you want, just in terms of ones and addition. Ints is described in terms of itself.